Problem statement number one. Let's say you spin a fair wheel that can stop anywhere between 0 and 1. Then what is the chance that it stops exactly at 0.5? Right there. What is the probability that it stops right there? Problem statement number two. Let's say you arrive at a bus stop and you know that these buses, they come every 10 minutes. Then what is the probability? What is the chance that you wait exactly 5 minutes for your next bus? These types of questions are answered by uniform distribution. This session is about uniform distance. By the way, answer for both of them is 0. And in this session, I'll explain you why it is 0 and how it comes out to be 0. The uniform distribution, the theory. Uniform distribution, generally, it refers to continuous distribution, not to your discrete distribution. The definition of uniform distribution is this: it is a probability distribution in which all outcomes are equally likely within a given range. That's your official definition. In plain English, it means this: that all intervals of equal length within AB are equally likely. Let's understand this through this example. Let's say this is your interval A and B. And let's pick up any 2 points. Let's say this is my point 1. Let's say this point is 3. And this is my second point, let's say 5. So if I pick up any other point, okay, with the same length as this interval, the length of this interval is 2. So if I pick up any 2 points with exactly same interval length, let's say this is 7 and this is 9, and the length is going to be 2, then the probability that your x falls between 3 and 5 is same as the probability that your x falls between 7 and 9. And that's because the length of my interval is exactly same. The total area under a curve equal to 1. This is true for all PDF, not only for uniform distribution. The PDF is given by this expression right here. This expression can be easily derived just by looking at this diagram. I'm going to derive this real quick for you. So this is the distance from here to here is b minus a, right? This is b minus a. And I also know that my area, okay, my area equal to 1. So this distance, okay, what is this distance? Well, multiply that distance, multiply by b minus a, okay, which is this right here, equal to 1. And you solve this thing, and the answer is 1 over b minus a. This is how I come with this expression, 1 over b minus a. This is how this one comes about. Okay, then uh, the probability that your x falls between x1 and x2 is the area between the curve and x1 and x2. So the probability that your x falls in this range right here is same as this area right here. Okay, the area under the curve and x1 and x2. And this area you can easily calculate. This is equal to your length of your base, which is x2 minus x1, multiply by the height. Okay, and your height is going to be 1 over b minus a, right? And so this expression is same as this. This is how this expression is derived. A side note, a common notation that is used for random variable x that follows a uniform distribution between two values a and b is generally denoted by this expression or this expression. Sometimes you'll see this or this. They both essentially mean that your x is following a uniform distribution. Suppose you have a fair wheel that can stop anywhere between 0 and 1 with the uniform probability distribution function. Okay, this is your fair wheel. It can stop anywhere between 0 and 1. What is the probability that it stops between 0.1 and 0.3? In other words, this right here. What is the chance that it stops in this range right here? What is the probability? Your next question is, what is the probability that it stops between 0.4 and 0.6? In other words, what is the chance it stops in this range right here? Okay, 0.4 to 0.6. And what is the probability that it stops at exactly 0.5? In other words, what is the chance it stops exactly right here? That's what you have to determine. In these types of questions, the first thing you do, you find your PDF fx, and that can be derived easily using your formula. If you remember, the formula was this right here. Okay, I can substitute, I can plug in my numbers a and b, and that will give me my PDF. I know my a is 0, right? Because it's saying uniform 0, comma 1. So my a equal to 0 and my b equal to 1. Substituting the values, my fx comes out to be this. So the height from here to here is equal to 1. That's I just derived. Now the probability that your x falls between 0.1 and 0.3, okay, which is this right here, okay, falls between these two range, is equal to the area, okay, this area right here. And this area you can easily find. That would be equal to your length of your base right here which is equal to how much? Well, this minus this, 0.3 minus 0.1 is equal to 0.2 multiply by your height, and your height is 1. So the answer is 0.20. In other words, 20% chance. There's 20% chance that your x, your wheel, is going to be between 0.1 and 0.3. Next question. What is the probability that your x is going to be between 0.4 and 0.6? Well, the answer is it's going to be the area between x equal to 0.4 and 0.6 and under the curve. So you have to find this area right here. Okay, that's what represents your probability. Well, this area you can find that easily. I know this length. This is equal to 0.2, right? 0.6 minus 0.4. Okay, right here, 0.6 minus 0.4 is 0.2, multiply by this 1 right here. Okay, multiply by 1, and the answer comes out to be 0.20. In other words, 20%. Exactly same answer. Okay, next one. What is the probability that the wheel stops exactly at 0.5? Well, the answer is the area between x equal to 0.5 and 0.5. So my 0.5 is right here. Okay. So the area between 0.5 and 0.5 is equal to 0 because it has infinitely small width. In other words, it's almost zero width. So the answer is 0. Suppose that a bus runs every 10 minutes at a bus stop. Okay, this is that bus that runs every 10 minutes, and that you arrive randomly at a bus stop. Your waiting time, in this case denoted by x, it follows a uniform 0 to 10 distribution. This is my A, okay, this is my B right here. In other words, you could be waiting for the bus anywhere between 0 to 10 minutes. So you could be waiting for 2.1 minutes, you could be waiting for 5 minutes, or 6.2 minutes, or 7 minutes, or 7.3 minutes. It could be anything, as long as it's going to be between 0 to 10. After you arrive at the bus stop, what is the chance, what is the probability that you wait, that your waiting time is less than 2 minutes, more than 7 minutes, between 7 and 9 minutes, between 5 and 12, between 11 and 12, and exactly at 5 minutes? So in these types of questions, first thing you do is find your PDF fx. Well, the expression for my PDF is right here. Okay, and I know my A. Okay, as long as you know A, as long as you know your B, you can derive your fx. But in this case, I know my A and B. This is my A, right? A equal to 0, and my B is equal to 10. So substituting your A and B, this gives me my fx. This is my fx right here. Okay, now let's find that you wait less than 2 minutes. In other words, what is the probability that you wait between 0 to 2, that your x, your waiting time, is between 0 and 2? So that would be this area between 0 and 2. So this would fall, the probability for that would be this area right here. And you can determine this area very easily. The area between 0 and 2 would be equal to your this right here, the length of your base, which is 2, times your height. And your height in this case is 0.1. 0.1. And the answer comes out to be 0.2. In other words, 20% chance. Is 20% chance that you could be waiting less than 2 minutes. All right, next one. What is the probability that you could be waiting more than 4 minutes? In other words, what is the probability that your waiting time is between 4 and 10 minutes? Remember, you can never wait more than 10 minutes because you know the bus comes every 10 minutes. All right, so in this case, the answer would be the area between 4 and 10. Well, my 4 is over here. This is my waiting time. My waiting time is 4 minutes over here and my 10 over here. So in this case, the area right here, that would be my answer. And my area would be the length of my base, which is 6, right? This from here to here is 6. And the height in this case is 0.1. 0.1. So 0.1 times 6 is 0.6. So the answer is 60% chance that you could be waiting more than 4 minutes. What is the probability that you would be waiting between 7 and 9 minutes? Well, that would be the area. So in this case, probability that x is between 7 and 9 is the area between 7 and 9. So let's go and find our 7. This is my 7 right here, and this is my 9. So the area between 7 and 9, which is right here, the answer would be this area. And this area would be equal to your 2, right? This length from here to here is 2 multiplied by your height. And my height is 0.1. 0.1. And the answer is 20% chance. Okay, what is the probability that you could be waiting between 5 and 12? My 5 is over here, and my 12 would be somewhere over here, 12. All right. So in this case, the answer is area between 5 and 12. So my area between 5 and 12. Well, this would be just only this area. That's it. Just this area. Because over here, your curve actually comes at the bottom, right? Your curve actually drops like this. So it is only going to represent this area. This is going to be equal to your this length from here to here, which is my 5, multiply by my height, which is 0.1. And the answer comes out to be zero point 0.5, which is 50%. There's 50% chance that you could be waiting between 5 to 12 minutes. Now, what is the probability that you could be waiting between 11 and 12 minutes? So my 11 is, let's say, somewhere over here, and my 12 is going to be somewhere over here. Well, that would be the area between 11 and 12. So in this case, the height of my fx, okay, my fx in this case is 0. 0, and this length from here to here is 1. So it doesn't matter what this length is. My height is 0. Because of my height of 0, this gets multiplied by 1 and the answer is 0, which makes sense because you could never be waiting more than 10 minutes. Remember, the bus comes every 10 minutes. So if you come at a bus station, no matter what happens, you are never going to wait more than 10 minutes. That's the maximum you're going to wait. Okay, what is the probability that you wait exactly 5 minutes? Well, the answer is area between 5 and 5, right? And where is my 5? Right here. So this 5 right here and another 5 right there. So area between 5 and 5 is 0, right? Because the width is 0 and my height is 0.1. So height multiplied by 0, the answer is 0. In other words, the answer is 0% chance that you could be waiting for the bus exactly 5 minutes.